This is Chapter 2, Elementary Programming, Programming Exercise 13, Financial Application, Compound Value. So, the question asks, suppose you save $100 each month into a savings account with an annual interest rate of 5%. Thus, the monthly interest rate is 0.05 divided by 12, which is equal to 0.00417%. After the first month, the value in the account becomes 100 times 1 plus 0.00417, which is equal to 100.417. Second month, follow the same formula. We will have 100 plus 100.417 times 1 plus 0.00417, which equals to 201.252. Now, what does this all mean? Well, this right here is the $100 that you're putting into your account. And this 1 plus 0.0417 is basically 100 times 1, 100 times 0.0417, and you add that together and you get 100.417. So why are we doing that? Well, the reason for that is because you're saving $100 each month and you're getting an interest of that $100. So this one is the $100 you're saving, and this right here is the interest that you're going to gain for that month. Combined together, and you get the savings plus the interest rate, which is 100.417. Now, we have to bring that money over to the next month, because not only do you have that money saved, you're adding another $100 into that saving. So now it is basically 100 plus 100.417 times 1 plus this times 0.00417, and you get 201.252. And you continue that every month. Every month you have your savings and you add another $100, and after that you get an interest, an increase of the interest for that month. And this repeats for as long as you continue this. So what we have to do is we have to write a program that prompts the user to enter a monthly saving amount and displays the account value after the 6th month. So how are we going to do it? Well, we could do it however we want, as long as the result is correct. You don't always have to follow this given formula right here. Of course, if you do, it'll be much simpler. You could just grab this and you could continue and make your own type of formula, as long as it follows through and resulting values correct. All right. And for example, what I wrote right here, let's say for month 1, I'm going to create a variable called total savings, a variable for my interest, and a savings that I'm going to put. Now in this case, this question is going to ask you to ask the user instead to ask the user how much they want to put in. Instead of 100, what if you want to put more or less? Depends on you and the user, right? In this case, let's just make it simple and say 100 for this visual example. We have our total savings, which start at 0, right? Because we have nothing in our bank, plus what we want to put into the bank, our savings. We're going to add that, we're going to multiply with the interest, and then we're going to add the savings again. Now savings, the reason for that, I separate put it out, is because right here I want to calculate for my interest. After I calculate for my interest, then I add the actual savings into there. The result is still the same, $100.41, right? I shorten it with just 2 decimal places, but the result is still the same. Now, the reason you want it to be the same is because imagine you're working for a bank and you're trying to create this application for them. Number 1, you don't want to give your customer too little money, the incorrect amount of money, or else the customer is going to get upset saying you're cheating them. But you also don't want to lose profit for the employer you're working for by giving the customer too much money, and your employer starts to lose money. So you have to make sure you're accurate on this. So that's why it's not exactly has to be 100% following the exact formula, but as long as your formula is correct, it's accurate, it's fast, and it's efficient, then it's good. All right. And of course, if you repeat this method, you continue this, right? The value should be the same for the next number, and so on and so forth, right? So 1.25 to 1.25, missing the third digit, third value, third decimal place, right? All right, so now moving on to our programming exercise, what I wrote here is just what I wrote in the PowerPoint presentation I showed. Is pretty much the exact same thing, right? Our savings, we start at 0. We are putting in $100 each month, and our interest is basically 5% divided by 12, which is basically calculated on a monthly basis because we're calculating interest every month. Now we run this, right? We'll pretty much get the exact same value, 302.50 on the third month, all right? Now when we go back on our third month, it's 302.50. All right, now all we really have to do is just change one thing, is just basically ask the user how much they want to save or put into their savings account each month instead. Now depending on what you put, that will change the resulting value. All right, now let me just remove this for now. And right here is your total savings in 6 months. Okay. Now let's say you let's say if you save $100 per month, and that is basically $608.81. So I don't remember that, right? If we save $100, then in 6 months we get $608, so basically 8.81 extra dollar interest over 6 months, with an annual interest rate of 5%. So let's ask the user, system.out.print line, enter how much you would like to save monthly, and we're just gonna update this for now. Instead of saying we save $100 per month, let's see what the user wants to save. Of course, before we do that, scanner input equals new scanner system.in, so we could read the user's input from the console. And we'll just say input.next. We'll just leave it as double, right? And that will edit from savings from 100 to another value. So let's run that and let's see. And let's say we put $50 per month instead. So we enter 50. Well, if we enter 50, we end up with $340.40. So let's save that. End up 304.40. So basically, in 6 months, instead of getting $8.41, putting half that means you get half as much. So what if we put double that? Well, answer's obvious, isn't it? We'll get double that compound interest. Right? Well, let's see. Turns out you get even more. Crazy, right? Well, actually, no, it's about double. Yeah, it's about double. So with $50, you get extra $440 in 6 months. $100, $880, $200, $1760. So that's compound interest at work, right? And That's pretty much it for this exercise. Right here, it's just using the exact same formula I displayed in the PowerPoint. Follow that and I get this as my result.